This problem is problem number 5 from the Hyperbolas worksheet. This one's actually going to be a little bit more tricky than the other two. And so this one looks very much like number 4, where it's not in the nice form that we're used to. However, it also has like y plus 3 and x minus 6, so it's kind of a mess. But the first step is we need to get it equal to 1. So we're going to divide by 144 on both sides. So 144 here, and then 144 on the left as well. So, what's going to happen here, we know that it's going to end up equaling 1. But on this fraction, the 16y plus 3 squared over 144, 16 over 144 will reduce. And so I'm going to use my calculator to help me with that. 16 divided by 144 is 0.1 repeating. And so if you're not sure what that is as a fraction, you can hit math and then frac number 1. And it tells me it's 1/9. So if we go back to this problem, this is going to end up being 9 on the bottom, 1 on the top, or we can just write y plus 3 squared over 9. Okay, 9 over 144, probably realize what that is, but just in case you don't, we'll do it on the calculator. 9 over 144 is 0.0625, and that as a fraction is going to be 1/16. Okay, so on our equation, it's going to be x minus 6 squared sorry. Over 16. Okay, so just like with circles, ellipses, parabolas, these numbers inside the parentheses tell us how far the center is translated. So the x is going to go over 6, and the y is going to go down 3. So the center is at 6, negative 3. Let's plot that over here. 1, 2, 3, 4, 5, 6, negative 3. Okay, this tells us that the x is going to be stretched 4 in each direction. And so we're going to go over 4, 1, 2, 3, 4. I'm kind of off the page here. And then for the other direction, 1, 2, 3, 4. And then the y is going to be 3 up, because square root of 9 is 3. So we go up 3 and down 3. Okay, let's make our box like we've done for each of the other ones. Alright, I'm going to see if I can move all this stuff over. Whoops, not that one. There we go, we can see it a little bit better that way. Okay, so the vertices and co-vertices, well, we need to figure out which way does this open, up or down, or left or right, up and down or left and right. So if it's y squared minus x squared, if we look at the previous problem, that was a y squared minus x squared, and it opened up and down. So same thing here, it's going to go open up and down. Before we do that, I'm going to draw in the asymptote lines while I've got the box all made. Okay, so let's sketch this. I'll use a red one. And so it's going to open up and down. And so this means that our hyperbola is going to open like this. And it's going to get close to this asymptote line but never cross it. So same thing here. And here. Okay, so we have it drawn. So that means that this is going to be our vertex here. And this is also going to be our vertex. So our vertices, we can look at the graph, are 2, 4, 6 over, so it's going to be 6, 0. And then 6, let's see, negative 3, 6, negative 6 for this one. Alright, our co-vertices we'll do in green. These are our two co-vertices. One right there and one right there. So that's going to be 2, negative 3. And then, let's see, we're over 2, 4, 6, 8, 10. So 10, negative 3. Alright, we have our vertices, our co-vertices. We need to figure out our foci. Let's do our Pythagorean theorem to figure that out. So a squared plus b squared equals c squared. A in this one was 4. B was 3. Remember, those are the x distance from the center and the y distance from the center. So that's 16 plus 9 equals c squared. 16 and 9 are 25. Or is it 16 and 9 is 25? I don't know. And then we square root. And c is 5. Whoa. So anyway, it's 5 away from the center. So our foci will go 5, 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. Alright, so these points here are going to be over 6 up 2. And then this is over 6 down 8. Alright, so far, nothing has changed a ton from the other problems. It's obviously not centered at 0, 0, so that throws things off. But, we sketch it, we'll find all the points. Everything else has been pretty much the same. The equations of asymptotes, this is where it's going to get pretty dicey on this problem. Nothing too bad. We've done this dozens of times in our lives. It's just going to take a little bit of a refresher. So, we are going to remind ourselves of the form of a line, the point slope form. So it's y minus y1 equals the slope times x minus x1. And so the slope is pretty easy to find. We're just going to count the rise over run with the box. The y1 and x1, you're just going to pick a point on these two asymptote lines. So, we'll start with a positive sloped line. And this line, it has a slope of, let's see, the rise is 3, the run is 4. So on these, m is going to equal 3/4 on the first one, and m is going to equal negative 3/4 on the second one. So negative 3/4 for that negative slope line. Okay, so let's divide this into two different parts. We're going to have two different equations for lines, and let's give ourselves a little bit more room to work. Okay, so it's going to be y minus, and let's pick a point on that line. And I guess the easiest one is the center. We know the center is at 6, negative 3. And so we'll use negative 3 for y1. So y minus negative 3 equals the slope times x minus, and then the x-coordinate of the center is 6. So once again, this is our point slope form of a line. This was from chapter 1 in Honors Algebra 2. And then I put negative 3 and positive 6 into this equation because the center of our hyperbola was at negative 3, or sorry, 6, negative 3. And that's a point on this line, on the positively sloped line. Okay, so we can simplify this a little bit. This is going to end up being y plus 3 equals 3/4 x minus 18/4. And then we can subtract 3 from both sides. And we get y equals 3/4 x. And let's see, this would be 12/4, so altogether we're at minus 30/4. Okay, so this is the equation of the positively sloped asymptote line. Alright, let's do the equation for the negatively sloped asymptote line. And I'll switch colors just so it doesn't look like one big black mess. So it's going to be y minus, and then, you know what, let's use the same center point because that's on the negatively sloped line as well. So y minus negative 3 equals the slope, which is negative 3/4, and then x minus 6. So the nice thing about that center point, you can use it in both equations because it is on both lines. Okay, so we get y plus 3 equals negative 3/4 x plus 18/4. Alright, we can subtract 3 from both sides and we'll solve for y. It's just kind of nice to have it in y equals mx plus b form. Now technically this is the equation of that line, but I kind of like it in y equals mx plus b form. So it's negative 3/4 x, and then if we have 18/4 minus 12/4, that's going to give us 6/4 altogether. Okay, so that's the equation of the other asymptote line. And that is all for problem number 5.